In this video, I am going to share yet another very interesting research which was done in McGill University, Mila, and New York University. Mahmoud Asran and his colleagues at Meta and these universities have developed a vision pre-training technique that's designed to address weaknesses in typical masked image modeling and contrastive learning approaches. They have called it in a tongue twister name image based joint embedding predictive architecture or I-JEPA. Now, I-JEPA is quite an interesting project and the way it works is also quite interesting. I-JEPA has used three components. First is a target encoder which is embedded an image target region, and then secondly a context encoder embedded the surrounding area, and then a smaller predictor network given the context embedding, and they tried to produce an embedding similar to that of the target embedding. All these three components were transformers, though other architectures would serve too, and all of them were pre-trained jointly on ImageNet 1K. Now, the flow is something like this. When you give or present an image or upload an image to this, the system split it into non-overlapping patches, and then it randomly selected four potentially, and then it randomly selects four potentially overlapping rectangular target regions, each of which was made up of contiguous patches covering 15% to 20% of the image. The target encoder produces embedding for the target regions, and then it randomly choose a context region, and then given the context embeddings and the masked patch embeddings of a target region, this produces an embedding for each patch in the target region. Now, an I-JEPA classifier that used WIT H14 encoder achieved 73.3% accuracy after about 2500 GPU hours of pre-training, which is quite impressive, I would say. And as you already know that in deep learning and generative AI, computer vision is getting more and more attention. So there's a really contention between learning details in this computer vision and then large scale features, because this is quite contentious in every way. This is where I-JEPA helps because it gives models more context for learning both details and high level features in the training set. And one last example in a very simple words, whenever you give a picture of a jungle to I-JEPA would see both the forest and the trees. So what it means is it will see the whole context, which is really groundbreaking. So that's it, guys. I hope that you enjoyed it. If you have any questions or if you are already exploring this research, then let me know your thoughts in the comments. And if you like the content, please consider subscribing to the channel. Thank you.